Okay, guys, last topic. And this is just finding the inverse functions of exponentials or logs. And just real quick, let me just remind you, how do inverse functions work? Well, the inverse of a function, if we apply the inverse, gives you back the original inside, right? F inverse of f of x is just this original x. It basically undoes it. And it works both the other way too. Their inverse, if it's inverse, it's going to be inverses of each other. So f of f inverse of x is just x back. And this is the case with exponentials as well. And one more thing to note though, this is true as long as you're domain of the inner function. Why is it got to be inner function? Because, well, that's where the x goes first, right? If x is not in the domain of the inside function, it doesn't make sense because this is the thing that happens first before the inverse is applied. Inner functions first, right? Okay, now inverse of an exponential. If I have an exponential a to the x, the inverse of the a to the x is the log base a. So log base a of a to the x is just that x back. And this is for anything in the domain of the inner function. Inner function domain is a to the x, which has a domain of negative infinity to positive infinity. That's because anything goes for exponentials, right? X can be anything. You're going to go on for the average to the left and right. We saw that in the last class. Okay, what about the log? Inverse of a log. This is the log function here. If I take a to that power, that's the inverse action. A to the x, a to the function, then I get x back. That's for anything in the domain of log, which is 0 to infinity. We've been talking about that, so I'm not going to belabor that point. Okay, so we already knew that, right? That's just a review. But now how did you find an inverse function? Do you remember that? Yeah, of course you do. So how do you find it? 4 steps. First, you replace f of x with y, right? And you swap the x's and y's, solve for y. And basically you're done at that point. But then you can rename the resulting function with the f inverse x. Okay, so let's try the remaining questions. Okay, we're just practicing finding our inverse functions now. And this process, same process we did back in the day when we first were introduced to finding inverse functions. Swap the x's and y's, solve for y. Yeah. Okay, so let's do it. Number 19. Let's work with blue. I notice the colors are much more vibrant when I look at them as I'm writing, and then I was looking at the videos. You don't really see the color as well, but whatever. Okay, so y equals to 2 to the x. Now, why is that inverse thing important? Because we're going to apply that right now. Watch what happens. The first step, switch. Well, actually, we did the first step is to write it as y. Second step, switch to x and y, right? 2 to the y. Now, third step, I want to solve for y. That means I want to bring that y down. How am I going to do that? I'm going to take the opposite, which is the natural log, or I'm sorry, not natural, but the log base 2 of both sides. Why am I doing that? Well, that's the inverse function, right? So if I take log base 2 of 2 to the y, that y just comes right down. And I'm stuck with log base 2 of x, and I'm actually done. Well, this is really done, essentially. But then, it's set to find the inverse function. So there was that one extra step just to rename the thing. And say, instead of y, I'm going to just rename it. F inverse of x is log base 2 of x. Now, don't be messed up by the fact that I'm writing it in the opposite order. It's the same thing, right? Equal sign is equal sign. But if it bothers you, you can reverse it. F inverse is log base 2 of x, like that. There you go. Number 19, done. Okay, in the future, I'm not going to take that. I'm not going to bother rearranging because it's the same thing, yeah. Left to right, right, left, same thing. Okay, number 20. I've got f of x equals to log base 7 of x. I'm going to take my first step here and change to y, log base 7 of x. What's the inverse of log base 7? It's 7 to the something. So I'm going to do that inverse in red again. And say 2 to the... Oh, wait. Sorry, guys. I'm getting ahead of myself. Forgot to take the most important step and switch to x and y's, right? Is that the most important step? I don't know. An important step. Switch x and y's. Now I'm trying to get y down, right? This is log of, not log down, but I'm trying to get out of the log. I'm trying to escape the log. So I want 7 to the x is 7 to the log. This is the exponent. 7 to the x is 7 to the log base 7y. But this action here undoes the log. So I'm left with, why am I whispering? It's left with just a y on that side, exactly what I wanted. And this on the left side is 7 to the x. Well, you know what? You're done. This is the y I was after. Let's just rename it. F inverse x is 7 to the x. That was the function I was after. That is the inverse function. No, just looking at it, I kind of knew that already, right? Like, you're just looking at the thing, you kind of knew that already. Because those are just the basic forms, and you could have just directly applied what was in our instruction box that we had in the topic 4. But I was just kind of going through the process. That's the same process we're going to use every time. Here's 21. I'm going to start writing y instead of fx. Y is ln of x minus 1. Again, I'm using the cursive L just so that my ln doesn't look like a 1n. Okay, and then next step is just to swap x and y. So x is equal to ln of y minus 1. Now I'm going to take my inverse function. Remember, ln is just kind of a hidden e base, right? So what I'm going to do is take e to this thing is e to that thing. Sort of doing this in a one step here. And what's going to happen, I'm going to get e to the x is e to the x. And e to the natural log is just whatever was inside that natural log. So it's going to be y minus 1. Now solving for y, add 1 to both sides. I got e to the x plus 1. There, oh, sorry. I was supposed to write f inverse x, yeah? I'm going to write it on the right side now. E to the x plus 1. I guess I do kind of care, huh? Okay, so there is. There's the inverse function, e to the x plus 1. That's 21 down. Oh, these are not too bad, yeah. These are not too bad, but I feel like this is kind of a good question style to ask. Not guaranteeing it's going to be on the exam, but I don't know. You know, I haven't written it yet, but this is kind of something that I think you should practice. Yeah, at least practice taking inverse functions, because you're going to see that. You're also see some of that in the next section in a different way, but still using that inverse property. Okay, start by just changing it to y, and then rewrite with x instead, and swap the x and y's, right? Now this is 6 to the something. I want to undo an exponential function by taking the log. Sorry, regular log. And what is the base? The base is the 6. So log base 6 of x is log base 6 of 6 to the y minus 1. Remember this action undoes that. There's some undoing action going on. And that's log base 6 of x on the left. This is y minus 1 on the right. Yeah, because these guys undid each other. How do I solve for y? Add 1 to both sides. I kind of feel like this is familiar, just going in the opposite direction using a log to undo the function instead, right? Y, oh, I'm sorry. What am I doing? Add 1 to both sides, that's just y. So this is going to be log base 6 of x plus 1. So, inverse function then. F inverse of, sorry, let me write it like this. Oh, I'm all over the place with the left and rights. F inverse of x is log base 6 of x plus 1. Yeah. There you go. That was 22. Okay, 23. 2 more. Almost done, guys. Almost done. It's like almost 1 o'clock in the morning for me. I don't know why I'm recording this at this time. I'm going to be lazy and just change that to a 3 for 23. F of x is 2 to the 3x plus 1 minus 6. But I didn't want f of x. I wanted to replace that with a y. Second step, change x and y's. Okay, now you might be wondering, how am I going to apply my inverse function as it is? Because I'm trying to bring this y down, right? Well, I got this minus 6 going on. I don't like that there. So I'm going to add 6 to both sides. Why don't I like that there? Because if I try to take the log now, I want to take that log of that whole thing, but this 6 is in the wrong spot. It's not upstairs. It should be upstairs in the exponent, but it's not. So I'm going to add it to both sides. It's going to give me x plus 6 is equal to 2 to the 3y plus 1. Now it looks like how I want it to look like. And so we're going to apply our logs to both sides. Not regular old log. Log base what? 2, yeah? Log base 2 of x plus 6. And this side, log base 2 of this thing. What happens here? This left side becomes log base 2 of x plus 6. Just like I have. This right side, this log base 2 undoes that 2. And you're left with the exponent. Just basically pull the exponent down. Now, how to solve for y? Subtract 1 from both sides. And then divide by 3. Can I do those together, guys? I'm going to do it in one step, okay? Divide by 3 also. So then my function, my inverse function, f inverse x, let's stick them to where they are. Stick to where they are. It's log base 2 of x plus 6 minus 1 over 3. There it is. It looks complicated, yeah? Like if you look at the answer, it looks like it's kind of complicated, but the process wasn't that bad, right? Really just very similar to the first one we did, just with some extra, minusing, plusing, and dividing by 3 at the end. It's no big deal. Okay, last one. I don't know why I'm leaving that to there. Okay, 24. This is f of x equals to 3 times log base 4, 5x minus 1. First step, write with y's instead. Okay, and then no, you're kind of almost there already, right? I can almost take my inverse function. Only thing is I don't like that 3 being there. So divide by 3 on both sides. I get y equals y over 3 is log base 4 of 5x minus 1. As I'm doing this, I'm just only now realizing I should have been leaving more space this whole time, like right over here, so I can apply that inverse function more easily. What's the inverse of log base 4? What's the base? 4 is the base, right? So this should be 4 raised to this power is 4 raised to that power. If I raise, I raise 4 to the same thing 2 times, should still be equal, right? And that's exactly what we're doing here. Oh, excuse me. Okay. 4 to the y over 3 is 4 to the log. Remember, these guys are inverses, so they undo each other, giving me just a 5x minus 1. Get out of here. And then now I'm trying to solve for... Oh, I'm sorry, guys. I'm sorry. I forgot to switch x and y's. Can I kind of just retroactively do this? Yes, I can. What's a good color so that we know I'm fixing a mistake here? Black. No, actually, I'm going to do black and I'm just going to highlight. That was a mistake. I forgot to switch to x and y's. Okay, so that was x. This is y, yeah? And I'm trying to solve for y here. So add 1 to both sides. Get 4 to the x over 3 plus 1. It's 5y. Divide by 5. Y is equal to 4 to the x over 3 plus 1 over 5. And last step, write it as an inverse. F inverse of x is equal to this whole thing. Copy. Paste. Ooh. And it's the first time I thought to do that. Okay. So there it is. And that was the last one. Okay, guys. Done. Have a great day. I'll see you in the next section.